Now, another related law based on voltage and current is Tellegen's law. Now, first, we had KVL, which described to us voltages, which are based on conservation of energy. We then had KCL, which this talked to us about currents based on the conservation of charge. We also had Ohm's law, which tied the two together to give us resistance, or rather, I should say resistance in quotation. Later on, we'll find that the more generalized definition is impedance, which, if you aren't familiar with impedance, you may not, you don't have to know it yet. Just a short definition though, impedance is just a general form of resistance that describes to you both resistance but also what's called reactance, which is how capacitors and inductors behave when given a current or given a voltage or given both. Now, because power is related to the voltage times current, it is also important to talk about a law that basically is based on conservation of energy and charge, called Tellegen's law. So Tellegen's law basically is an extension to KVL and KCL, but applied to power. It states that the sum of all power is equal to zero. Similar to the conservation of energy, the sum of all power absorbed is equal to the sum of all power delivered. And this should make sense, right? If you supply 5 watts of power, it would make sense that an element would try to use all 5 watts of power and distribute it among different elements where appropriate. You can't exceed 5 watts, but you can definitely go under for practical purposes where that rest of that power might be lost as heat. But in general, 5 watts never creates more power. You can't get 6 watts out of 5 watts. And for certain, you can't destroy that power either. Remember, although you can read maybe 4 watts given, like, say, 5 watts of power, that extra watt of power might have been lost to heat. So it's a very similar it's a similar idea to KVL and KCL, but just applied to power. And that's basically what Tellegen's law is. Now, it's based on power being equal to plus or minus the voltage times current. Now, plus, as we discussed before, means absorbed, where minus is delivered. And just in case, recall that absorbed and delivered are relative terms. Absorbed just means the current sees plus to minus. Delivered means the current sees minus to plus. And from there, we're able to basically have Tellegen's law. Okay, thank you.